class. Okay, I hope everybody can switch on your video, because I can see your face, since this is our first class. Okay, for tonight. Okay, so before that, okay, let me introduce myself. Okay, my name is Dr. Khairul. Uh, Currently, I'm working in the School of Material, and then start from this week and onwards until mid-semester break. Okay, I will take over the class for EBB511 material characterization. Okay, so for my part, this week and onwards, okay, I will cover more on the surface analysis technique. Okay, I think everybody can hear my voice, right? So if you can hear my voice, can you put some emoji on your screen, okay, by clicking the reaction. Okay, so you meaning that I can see you can hear me well. Okay, great. So everybody can hear me well. Okay, so all right, great. So all right, for tonight, okay, I not plan to cover until 2 hours class. Okay, I not plan to cover that for 2 hours class. Okay, I just highlight the G's, or the fundamental one of the type of the surface analysis technique in material characterization. Okay, so for tonight, I will cover the X-ray diffraction analysis. Okay, may I know, maybe you can write in the chat box, okay, whether any one of you have experience
Excuse
dealing
me,
with this
Professor.
XRD analysis before. Can you jot down, or can you write in the chat box? Any one of you have experience? Do the testing, analyze the results, or you handle the machine. Anybody? Can you write in the chat box? Okay, any one of you? So, because I need to understand your knowledge first before I can start to deliver the content for my slides. Okay, so I assume everybody not uh, don't have any experience dealing with this XRD analysis. Okay. Okay. For this attendance, okay, Yiming, for this attendance, it's no need, because this webback, I said, after our class complete, I can automatically capture your attendance based on your login activities. Okay, meaning that once you log in the WebEx, and then after this class finish, I can auto capture. Do not need to sign any attendance, because I can capture automatically your attendance. Okay, all right. So before I start my class, okay. All right, great, Navid. Okay, so I good. So meaning that all of you don't have experience dealing with this XRD analysis. So therefore, for my class, I try to use the basic knowledge, okay, in order to uh, teach you, okay, regarding the XRD analysis. Okay, for your information, when you when you come to school, okay, later on for your experimental works, okay, because I think after midterm break, okay, maybe I think week 10 or week 11, okay, you will have this kind of uh, lab work for this subject. Okay, maybe a part of it, a part of that, I will teach you, I will demo you how this XRD machine works. All right. By the way, when you come to the school, and then you do your own project later on, I think in second semester, okay, you, I would say that I will guarantee that most of you will use this kind of analysis in order to perform your project, as well characterization of your samples. Okay, so therefore, this topic is very important for you to understand. All right, so let me share my screen with you. Okay, uh, let me share my screen with you. Okay, can you see my screen? Okay, I try to make it PowerPoint view, power full presentation mode. Okay, thank you very much. Okay, so for tonight, okay, I will cover uh, the first part, okay, for my topic, okay, regarding the surface analysis technique. Okay, here is my name. Uh, for this XRD, currently I was an instructor for this kind of lab for the XRD analysis. All right. So, all right, for XRD, okay, normally in XRD analysis, okay, normally generally, we use the powder type of samples, okay, in order to use for the XRD analysis. However, uh, for XRD machine, okay, for XRD machine, actually we can use basically three types of materials. Okay, number one, powder. Number two, we can use thin film, and number three, we can use the liquid type sample. Okay, but in our school, normally we run the XRD analysis in powder form. Okay, as you can see on my screen. Okay, my question to you. Okay, my question to you, everybody. Okay, maybe you can write as maybe you can write in the chat box. Okay, okay. I give you a simple example. Okay, let's say uh, let's say you have two different powder. Okay, two different powder. Okay, number one, you have powder. Okay, you have two powder A and B. Okay, both of them have similar color. Let's say white color. Okay, and then this powder also have a similar texture. Okay, maybe soft, something like that. And also this powder also uh, have a similar smell, okay, between those powder. Okay, my question to you, based on this character, okay, the color, the smell, as well the texture of the powder, can you identify, okay, for example we want to talc, something like we use for the to put on our face, something like that, the powder, the talc powder. Okay, we put on our face. Okay, let's say you have two type of white powder, and then you want to identify, okay, which one is talc, which one is not. Okay, so in this case XRD is useful, okay, in order to identify either powder A or powder B is belong to the talc specimens. Okay, so later in my slide, okay, I will show to you, okay, how to differentiate. That's why I put here, okay, XRD analysis is the quickest and easiest way to determine the phase. Okay, that in this case, we want to measure the compound, the type of the compound that presents in the powder by using the X-ray analysis. Okay, here is the setup for the XRD analysis. Okay, not the setup. I'm not setup actually. The parts, okay, that have in the XRD machine. Okay, I think this one you should understand well. Okay, because uh, normally for EBB511, regarding for the XRD analysis, I always ask the question, the principle of the XRD analysis. Okay, maybe you can use this kind of setup, okay, in order to explain how this XRD machine works. Okay, by the way, in order to explain this kind of assembly in the XRD machine in e-learning portal, okay, I'll show to you how these parts works. Okay, let me stop sharing my screen first. Let me open the e-learning portal. Okay, e-learning portal. Just a minute. I open my e-learning portal. I upload something in the e-learning portal. Okay, let me show to you. I think the easiest way is to show. Okay, I share my screen with you. Let me share. Okay. Okay, can you see my screen now? Okay, thumbs up a little bit so I can see whether you are still follow with me or not. Okay, great. Okay, in e-learning portal, okay, actually I upload 11 videos. Okay, 11 videos how I perform the XRD analysis. Okay, you can see I upload in the playlist. Okay, I do quite comprehensively for this video. Okay, that's why I not plan to give a long lecture for this, because for you it's easy for you to see instead of I explaining the things. Okay, so in this case I give introduction, I give sample preparation, I also sample preparation in powder form, and also type of XRD, and how to set the sample, and others lah. Okay, so I give you example. Okay, here how I prepare. Okay, here.
Okay, hi everybody. Okay, now I want to show you the
Can you
most
see my
interesting
screen?
part for
Can you hear
XRD
the
analysis.
audio
Okay,
on the YouTube?
the machines. Okay, in our school, School of Material and Mineral Resources Engineering, University of Science Malaysia, we have two type of XRD machine. Okay, as you can see
You
here.
hear the voice
Okay,
from
the
YouTube?
D8 Brooker. Okay,
Thumbs up
the
a little bit.
XRD machine.
See
I
whether
think
you
the
are
most advanced XRD machine
whether
that
you
we
can
have now
whether you
for
can
XRD
hear or not.
analysis.
Okay,
And
thank
then
you, Eugene.
second, we have the small version of
Okay, here,
XRD machine.
as you can see on my screen now, okay,
XRD
actually here is the how I
Okay, for your information,
explain to
the
the student for
function
the
for
demo.
both machine is
Okay,
same.
when you come to the
Okay,
lab
but the
later,
only
after the
different
midterm
the
break, I think
size and
maybe week
capacity.
11 or 12,
Okay, for
you
big machine,
can
normally
attend this
the
kind of,
scanning time is short
oh, you cannot hear me?
compared with the tabletop, but the function is still same. Okay, so later on, our assistant engineer in designing will demonstrate to you the real how we
But you
prepare
can
the
hear
sample and run the
the sound
examination
from the
until
YouTube?
we get the peak inside the computer. Please.
Okay, great. So I
Okay.
stop here. Now can you hear me? Okay, great. Maybe the audio is redundant. Okay, so later on, I will also upload another set of video from my YouTube channel. Okay, actually, I use YouTube, my personal YouTube channel, in order for education. So therefore, you can go through my this video, and then later on, I will upload another set of video. Okay, in order to explain how this XRD principle works. Okay, and how XRD principle works. Okay, so therefore, you can watch this video, and for sure you can easily understand the fundamental that I tried to say in the slide later on. Okay, so later on I will upload another set of video. Okay, so I stop sharing and I share back my screen with you. Okay, here is the setup. I think I don't want to explain more on the setup for this machine, so you can watch my video later. Okay, uh, bear in mind. Okay, bear in mind. For this XRD method, okay, we want to identify number one, phase that presents in the specimen. Okay, what is the meaning of phase? Okay, for example, uh, you have this kind of two powder, okay, A and B, okay, and then you want to identify, okay, which one is the salt, okay, salt or sugar. Okay, normally I give simple example, salt. Okay, let's say you have two white powder, powder A and powder B, and then you want to identify uh, which which powder is belong to the salt. Okay, may I know what is the chemical name for the salt? Can you write in the chat box? Chemical name, chemical formula. Sorry, chemical formula, not chemical name. For the salt, can you write? Okay, good.
NaCl,
Okay,
sodium chloride.
yes, sodium chloride. Okay, so okay, sodium chloride we call it as a phase. Okay, therefore, in this case, you have a two powder, powder A and powder B, with the same color. same texture, same smell, but you want to identify which one is a salt. So therefore, you need to run this kind of XRD analysis, and you can get explicit answers. Okay, which powder is belong to the sodium chloride or salt. Okay, number two, please bear in mind. Okay, for this XRD analysis, okay, we can measure only crystalline material. Okay, crystalline material. Okay, what is the meaning of the crystalline material? I think you should you should try to search what is the definition of crystalline material. Okay, you must understand this. Okay, I give you tips. You must understand the definition of the crystalline materials. Okay, you must understand, number one, what is the crystalline. Number two, what is the semi-crystalline. Number three, you must understand what is the amorphous. Okay, crystalline, amorphous, and also semi-crystalline. These three terms you must understand, but I didn't put on my slide. But I explained in my video that I uploaded just now in e-learning portal. Okay, I hope maybe you can spend some time, watch this video anytime you are convenient with. Okay, watch the video. My advice to you, please watch the video, because the question for the final exam, for the quiz, as well for the test, might come out from this kind of video, because my lecture only just explain the basic part of the videos. Okay, so here, how the XRD works. Okay, from the X-ray source, and then they will bombard the samples, and then the detector will detect the signals, and then the detector will translate the signal into the computer software, and then finally we have the data acquisition, and then finally we get the face identification. Okay, I don't want to touch this more because I explained in my video later on. Okay, so okay, what is the XRD spectroscopic technique? Okay, spectrum means that the spectroscopic meaning that from the X-ray source, as you can see, let me change my. Okay, can you see my red pointer? Okay, can you see my red pointer? Okay, great. Thank you, Vincent. Thank you, Dash. Okay, Sarang, thank you. All right, here. Okay, what is the spectroscopic technique mean? Okay, spectroscopic means that, okay, after we supply the X-ray source from the X-ray tube inside the XRD machine, and this X-ray source will bombard the samples, and then this sample, okay, since that these crystalline materials, okay, got this D value, or D, we call it as an interplanar spacing. Okay, I write in the chat box. Okay, please find out what is this terms mean. Okay, I put in the chat box. Let me type first. Okay, interspacing. Okay, so you must understand. Oh, sorry, I directly sent to Morgan, not everybody. Sorry, Okay, I put in the chat box. Okay, you must understand what is meaning of the interplanar spacing. I hope you can jot down somewhere on your notes. Okay, you must understand what is the definition of interplanar spacing, because as you can see on my screen now, okay, as you can see on my screen now, okay, when the X-ray source was bombarded from the X-ray tube, and this X-ray source will bombard the specimen, or the crystalline materials, and then this crystalline material have something like spacing between the atom. Okay, and then this X-ray will pass through the spacing, and then this spacing will collect. The detector will collect the signal from this spacing value, and then they will give you the spectrum, or the signal, and then this signal will be captured from the software, and then the data will translate into the into the graph. Okay, so next, lattice arrays and brevis lattice. Okay, this kind of lattice array. Okay, remember, just now I explained to you, you must understand what is the crystalline, what is the amorphous, and what is the semi-crystalline. Plus another one, you must understand what is the polycrystalline material. Polycrystalline. Okay, maybe you need to jot down somewhere. Okay, what is the difference between crystalline versus polycrystalline? Okay, I repeat again, you must understand how to differentiate between crystalline and polycrystalline materials. Okay, this kind of question is very popular. Regardless, either I'm teaching undergraduates or PhD as well, the master student, you must understand this term well. Okay, number one, crystalline. Number two, amorphous. Number three, semi-crystalline. Okay, that's the number one. Number two, you must understand how to differentiate between crystalline versus polycrystalline. Okay, so this one a tips for you. Okay, you must understand how to differentiate this, because once you understand these terms, okay, it's easy for you to understand the whole concept in XRD analysis. Okay, another tips that I want to give to you is, okay, based on this crystalline, amorphous, semi-crystalline, and also polycrystalline, you need to give example, okay, the XRD graph from this scanning analysis. Okay, what I mean, okay, I can draw here. Okay, what I mean, okay, let's say you made one table. Okay, you made one table. Okay, the first column at the left, you put type of crystal: amorphous, polycrystalline, crystalline, and also semi-crystalline. Okay, that's a first column at the left side. The right side, you need to put example of XRD peaks pattern produced from this type of crystalline. Okay, type of crystal. So you must understand how to give simple example in order to reflect, okay, this material is polycrystalline or amorphous or semi-crystalline. Okay, so for the Brevis lattice parameter, okay, for this one, I don't want to go deep, okay, okay. Actually, this one you can get directly from the software. Okay, so I no need to explain this because this one for the first year student. Okay, my concern to you is you must understand, okay, what is the meaning of cubic, tetragonal, orthorhombic, monoclinic, triclinic, or rhombohedral or hexagonal. Okay, there are some rules to follow on this. Okay, but for your level, I didn't ask this question. Definitely no, in the test or quiz or final. For me, this one is too fundamental for you to understand. Okay, because you are the master student. Okay, I think you must understand how to differentiate between these cell types. Okay, I will explain later on in the next slide. Okay, so the next slide. Okay, here for me is very important for you to understand. Okay, maybe you can put on your note. Okay, please put some remarks. Okay, on this slide. Okay. All right. So in this case, you must understand how to get this kind of crystal unit cell type. Okay. I don't ask you to remember. No need to remember this. Okay. I just want to you to I mean, how I say, to imagine. Okay, imagine how this cubic, tetragonal, orthorhombic, mono, tri, and also hexagonal looks like. Okay, here is the atomic atom arrangement structure. Okay, on the crystalline material. Okay, so no need to remember this. Just you need to understand how this kind of unit cell types can be produced. Okay, here is very important. Okay, maybe you can put later on. I will share this slide on your, I mean, inside the e-learning portal. Don't worry, but you must take note somewhere, okay, on your notes, okay. Please, please, okay, understand this slide thoroughly, okay. All right. So I think I've summarized this into three section. Okay. What is the application of XRD? Number one, you can identify the phase present as I mentioned just now. Okay. For example, like you said, sodium chloride and others. Okay. Number two, you can also identify quantitatively. Okay, quantitatively, uh, the the relative amount of compound phases in a sample or the phase mixture. Okay, what is the quantitative measurement? Okay, how I say, how I want to give simple example. Okay, I think number one, everybody understand the simple example that I just give at the beginning of my class regarding the sodium chloride example. Okay, you have two powder, same color, same texture, and same smell, and then you want to identify which one is belong to the sodium chloride. That's we call as a phase identification. Okay, what is the meaning of quantitative measurement? Okay, let me give you simple example. Okay, imagine I think I hope everybody I mean I hope you drink a coffee, okay, milk coffee. Okay, imagine you have a coffee powder and then you have the milk powder. Okay, and then you mix together and mixture and blend or whatever lah, right? So in this case, okay, let's say you add certain amount of the coffee powder and certain amount of the milk powder and you mix together. Okay, and then from this mixture you run XRD analysis. Okay, from XRD analysis you can identify in percentage how much coffee powder that you add and how much milk powder that you add. Okay, the total must be 100%. Okay, you get my point. If you get my point, please put thumbs up on your screen so I can see whether you understand my example correctly or not. Okay, great. Aziz, thank you. Ina, Vidya, thank you. All right. So I repeat again. Okay, for quantitative measurement, you have coffee powder and you have the milk powder. Okay, but you unknown how much this coffee powder and how much this milk powder that you add to make a milk coffee. Therefore, you blend this powder together and then you run the XRD. Okay, and then from this XRD, you can identify how much coffee powder that you add and how much the milk powder that you add in 100% amount. So after you scanning, maybe you can find out that you add 45% of coffee powder and maybe another 55% of the milk powder. Okay, that's the second application of XRD. Okay, number three, decide as well. Okay, the lattice parameter and also the Brevis lattice symmetry. Okay, what is the lattice parameter? Okay, from this XRD uh, analysis as well, okay, you can identify whether your crystal, okay, either cubic, monoclinic, hexagonal, triclinic. Okay, later I will give you some example for this third application. All right, maybe for you it's very complex for you to understand, but later I will show to you the simple example to understand this kind of application. Okay, let me change another slide. Okay, number four, you can I mean decide as well the crystal structure. Okay, the crystal structure. Okay, the crystal structure means that, as I mentioned just now, you can identify either this one is crystalline, polycrystalline, amorphous, or semi-crystalline. Okay, number five, you can also identify the orientation of the crystal. Okay, the orientation of the crystal. Okay, may I know, did you learn in previous class in any subject regarding the orientation of the crystal? For example, I wrote in my in the chatting box like this. Did you learn this one previously in other subject for mixed mode program for this analysis? I mean, using XRD, you can decide the orientation. Anyone can respond? Did you learn this one in the class? Okay, I saw some of most of you didn't learn yet. Okay, so no problem. Later, in the next class, I will explain more in detail. Okay, and then number 6, we can measure as well the crystallite size or microstrain. Okay, this crystallite size is really important for you to understand. Okay, later on I will explain in one simple slide regarding this crystallite size. Okay. Let me, okay. All right, here I put some schematic diagram, okay, I take from the books, okay, regarding the how this XRD works, okay. For me, I not plan to explain this much, okay, because I put quite comprehensive in my explanation in the video. So later you can watch my video, okay, regarding this kind of explanation. Okay, so the next slide, okay, here is the, okay, I should go back. All right. All right, before I explain this slide, okay, actually, uh, for the X-ray source, okay, for the X-ray source, normally we can use a different type of the metal source in order to generate the X-ray source. Okay, in this slide, okay, I give you a simple example, okay, for the different type of the anode that we use in order to create or generate the X-ray sources. Okay, don't worry, do not remember this. No need to remember. Okay, just remember in our XRD machine that set up in our school. Okay, no, in our school we use copper anode. Okay, copper nickel. So meaning that we use copper as an anode and then we use the nickel beta filter to filter and then generate the X-ray sources. Okay, do not remember this. Okay, this one just for your understanding. Okay, all right. Here, I want you to jot down some important remarks here. You need to understand this equation. Okay, where to get this? Okay, actually we derive from Bragg's law. Okay, Bragg's law. Okay, so at the moment, okay, for this EBB511, I didn't ask any calculation question. Don't worry. Okay, for my topic, I didn't ask any calculation question. Okay, but okay, they have a but there. Okay, everybody must understand how to derive the Bragg's equation. Okay, I don't want to explain here. Okay, you can search in Google. There's thousands of example how to derive the Bragg's law. Okay, how to derive the Bragg's law. All right, so maybe in the next assignment, or I mean assignment, I think. Okay, I will ask this question again. Okay, I will ask you how to derive. Okay, you must understand this. Okay, how to derive, because from the derivation, you will get all this equation throughout the derivation process. Okay, what is the D means, what is either A means, what is the HKL means. Okay, HKL meanings is the I would say the value that you get from the XRD calculation. What is the H, what is the K, what is the L? You must understand this. Okay, A is what, and also the D is what. Lambda is what? Lambda definitely is the wavelength that you use in the XRD analysis. In our case, we use copper plate and also copper nickel, meaning that copper as a anode and nickel as a beta filter. Okay, you derive from there, and then you will get this kind of equation. Okay, actually from the derivation, we can use a lot of, we can get a lot of data from there, or the result. Okay, from the calculation, you can decide the d-spacing value, you can decide the crystallite size, you can decide the lattice size, many things. That's why your task now, you must understand how to derive. But I don't want to ask you now how to derive it. Maybe you should go through in the literature review and how to derive this equation. Okay, here I give you some example. Okay, I give you some example how we derive the not derive. Okay, here is the example of the crystal lattice structure. Okay, actually from the calculation or from the derivation, you can find out, okay, your crystal lattice structure is what. Okay, here is the I repeat again, like triclinic, hexagonal, rhombohedral, orthorhombic, and face center orthorhombic. There's a lot of crystal lattice structure. Okay, here I give you example, HCP. Okay, what is the HCP means? Okay, BCC is body center cubic, FCC is face center cubic, and others. Okay, all right. Before I proceed, any question from you? Okay, maybe you can write in the chat box. Is any concern or any question or you want to ask? You can unmute your mic and you can ask the question.
Prof, can we have 2 minutes break, please?
Yeah, sure. 2 minutes break, yeah?
Yes, please.
All right, sure, no problem. So everybody, I give you 2 minutes break. You can, prepare your drinks or coffee, and we can continue in 2 minutes time. All right? Okay, shall we continue back? All right, so we continue back. Okay, let me check how many slides left. Okay, let me check. Sebenarnya, okay. Okay, great. So let me continue back. I share my slide with you. Okay, so we continue back our class. Okay, before we rest, okay, uh, I finished until here. Okay, now I want to explain to you. Okay, this please listen carefully and please jot down. Okay, try to capture as much when I say something important in this. I mean principle. Okay, okay. So I want to spend a little bit time to explain about this. Okay, number one. Okay, for this instrumentation, geometric arrangement of X-ray, diffractometers. Okay, okay. In this case, okay. So, in this mechanism or principle, okay. Imagine, okay. Imagine. Let me change my pointer. Okay, imagine this crystalline material. Okay, you put at this sample stage. Okay, at this sample stage. Okay, and this one, the X-ray from the X-ray source, okay, will bombard the monochromator, and then this monochromator will reflect the X-ray source and bombard the samples. Okay, when this bombard of samples, okay, when this X-ray source bombard the surface of the sample, the signal will reflect, and then the X-ray detector will detect the signals. Okay, what I try to explain here is that, okay, okay, how I want to explain. Okay, let me give you some sample. Okay, can you see my screen now? Okay, no, huh? Let me switch on the background. Okay, because none. Let me. Okay, I think it's easy now. Okay, yeah. Wait a minute. I want to close this setting. Okay, I give you a simple example. Can you see my bottle here? Okay, can you see my bottle? Okay, great. So imagine I have two bottles here, one small, one big. Okay, one small, one big. Okay, imagine the small bottle is the X-ray source, and
Prof, we cannot see.
the big bottle is the detector, like this. Okay, what I try to say is that when the angle of the X-ray source and the angle of the reflection must be same, need to be same. Okay, for example, when this X-ray source come 30-degree angle, okay, and the X-ray reflection from this surface of the specimen also must reflect at 30-degree angle, and this one can continue until 90-degree. So meaning that when the X-ray source scanning your surface of the specimen, at the same time, detector also will detect the signal following the angle of the detector from the X-ray source, like this. Okay, meaning that it will move simultaneously at both sides with the same angles. Okay, that's why how the Bragg's law has been derived. Okay, so meanings you must understand this principle carefully. Okay, and this working principle. Okay, not mechanism, working principle of the XRD. Okay, from this working principle, you can watch from my video in the e-learning portal. All right, so continue. Okay, here is the atomic planes. Okay, what is the atomic plane mean? Okay, in the crystalline material, unit cell is the basic repeating units. Okay, the above example is for the nickel oxide. Okay, the red large sphere are oxygen and the green smaller spheres are nickel. Okay, for this kind of example, what is the atomic plane mean? Okay, the atomic planes meaning that, okay, this one how this crystal has been arranged. Okay, in this case, okay, from this slide, you can see two important numbers. Okay, can you see my pointer here? I point 200 in bracket and 220 in bracket. Can you see on my screen? 200 and 220. Okay, this 200 is not a number. This 220 is not a number. Okay, actually, this 200 and 220 is referred to HKL value. Okay, from this HKL value, you can decide your atomic plane is what. Either is monoclinic, rhombohedral, tetragonal, and others. Okay, later on I will give you example. Okay, so this one 200, 220 have give you different meaning. That's why I go back to the previous slide. Here, you see the HKL values. Okay, these HKL values actually come from here. HKL 220, H is 2, K is 0, L is 0. Here, H is 2, K is 2, L is 0. Okay, from this calculation, you can get plenty of the answers from this, from the Brecht's law, from the Brecht's law derivation. Okay, so here is the example. Okay, see my pointer. Okay, here is the example of single crystal specimen. Single crystal specimen. Okay, how we can say this one is the single crystal specimen? Okay, meaning that in this kind of sample, there is only single crystal, meaning that something like how I say, the orientation of the crystal is in the same direction. For example, as you can see here, this one aligned in horizontal. This one, the crystal is aligned on the big angle on the right side. Okay, here the size of the crystal is equal. So therefore, when this X-ray source bombard the sample, okay, this kind of crystal arrangement will inform you, okay, this peak was detected at which plane. Okay, when you later on in the future, okay, for me it's very difficult for me to explain on this. Okay, when you watch my video, you can get this point, right? So meaning that at this peak, okay, we can detect the crystal has been formed at plane 100, and another peak we detect the signal for the crystal material at 110. Okay, and this one also we detect at 111. Okay, so don't worry. Maybe next class we will recap back. Okay, this kind of sample. Okay, so next I give you some example. Okay, here is the polycrystalline. Okay, you can see. Okay, it's two different. Okay, let me change back. Okay, here is the single crystalline, meaning that all the crystal arranged in the same direction. Okay, in the same direction. Okay, so in this case, we call it as a single crystal material. Okay, here is the polycrystalline, meaning that we have the crystal, but the orientation of the crystal can be in any direction or any orientation. Okay, that's why when this X-ray source bombard the surface of the specimen, okay, we can decide, okay, this polycrystalline material, okay, refers the peak of the measurement refer to which plane. Okay, so that's why I ask you to understand the difference between polycrystalline and also the crystalline material. Okay, so this one, the ICDD file number. Okay, what is the ICDD? Okay, ICD is International Convention of Diffraction Database. Okay, meaning that something the library. Okay, I think you no need to understand. You need to understand this, because normally in our software we have the library in order to get the answers for this. Okay, here is the example when we extract from the ICCD library. Okay, from the ICCD library, we can get this kind of database. Okay, this kind of database. All right. So okay, next. Okay, for example, when you run this, okay, for example, when you run this kind of XRD analysis, okay, you get this peak. Okay, can you answer me? This crystalline or polycrystalline based on this data? Can you answer whether this one polycrystalline or crystalline material? Okay, Eugene answer crystalline. Hong answer polycrystalline. How about others? How about others? Polycrystalline or crystalline?
Crystalline.
Okay. All right. I saw some of you answer poly, some of you answer crystalline. Okay. I do understand. I expected this kind of answer when I asked this question to you. But don't worry, I don't want to explain tonight. Maybe in our next class, I will explain on this. This is very, very important. And this kind of question is frequently asked, either in quiz, test, or final exam. Please take note somewhere on your notes, okay? So you must understand how to differentiate this peak. That's why I told you you need to make one table for you to easy to refer later. Okay, easy to refer later. So in this case, I hope everybody can do this table. Okay, so next, crystallite size. Okay, what is the crystallite? Crystallite size. Okay. By the way, can we stop our class until this slide? Is it okay? So next class, what time normally Prof. Karunisa conduct the class? As I not remember, if I'm not mistaken, normally the next class on next Wednesday, right? On next Wednesday around night, right? Malaysia time, 8:15 Faridas. As I remember, Monday is 8:15. Okay, can we make the class on Wednesday around this time, 8:30? Because 6 p.m. is not convenient for me to conduct a class. Is it okay for everybody? So we change on Wednesday. Can we change the class around this time? Oh, 8 to 9, you have EBB522. Oh, okay. All right. So in this case, how about we conduct a class 9 to 10? Is it okay, Navik? Okay, and for me, it's for me because uh 8 to 10. Okay, all right, all right, all right. Because if I made 5 o'clock, I think not of you not I mean maybe not all of you available, right? Okay, let's say what time you free? Night. Which day? Either than Monday. Monday we fix the class like this. 8:30. How about others? Other day? Uh, Tuesday, Thursday, Friday night. But I don't want to. I don't want to bother you Friday night, because Friday night normally Some of you have some occasion with your families or your friends. So how about other days? How about tomorrow night or Thursday night? Oh, yeah. How about Thursday? Thursday, 8 p.m. or 8:30 like this. Is it okay for everybody? Thursday. Okay, good. So we get good agreement. So this Thursday we have a class. So we change our class Monday and Thursday for my part lah. So meaning that we still have 3 weeks left before the midterm break. So my class on Monday and Thursday. Okay, so everybody agree with me? Oh, all right, 5 to 5. Oh, okay, only you cannot join the class. All right, so okay, so therefore, in this case, let's say if I conduct the class 5:30, is it okay for everybody? 5:30 on the Wednesday, or anybody got problem because maybe some of you working, maybe working or do the part time, because I plan to finish before 7 because it's a prayer time around 7. So for me, it's not convenient for me to make the class 6 to 7 because sometimes I need to drag a little bit the class in order to get in order to meet the time after 6. Okay, all right. So in this case, we don't have any option. Okay, we don't have any option. So because everybody is redundant with other class as well. Okay. Okay, Raja. Okay, you working. Okay, okay, okay. All right. So no problem. So we stick as it is at 6 o'clock. I try to accommodate all of you the same time. Okay. For me, I can adjust my time, no problem, because uh, the important is that I can accommodate your time, so everybody can join and listen my class. Okay. So we continue this Wednesday, 6 p.m. as usual. No change at all. No change at all. And then the Monday we still fix with the same class. Okay, so I think that's all for today. Because for me, 2 hours class is too long for online. Okay, I don't like to teach too long for online class. Okay, I rather like give example rather than I give a lecture. Okay. By the way, before I end my class, okay, later on I will upload one. I will upload another YouTube videos in my section in e-learning portal. I hope everybody can go through all these videos, okay, before my class on this Wednesday. I do really hope, okay, because as I mentioned at the beginning, this lecture I just covered the fundamental, but the demo side, the actual measurement, the experimental that we perform, I show in my video. Okay, I hope everybody can go through, and then we meet again on the Wednesday, and from there I hope you can get a clear picture about the XRD analysis. Okay, everybody. So this video I record, and then I will upload in e-learning portal once the link available. Okay, so don't worry, my part I always put in the YouTube because for me YouTube is more convenient. You can watch the YouTube when you lay down on your bed, or you take a bus or train, so you still can watch my videos through my YouTube channel. All right, so everything I put in, I uploaded in the e-learning portal later on. Okay, I think that's all. Nice to meet you, all of you here. If you have any question related, you can feel free to text me. Okay. All right. I think I received a WhatsApp from Sarang. Okay. I think I received WhatsApp from Sarang. Okay. I'm not sure he or she. Can you see? Can you give thumbs up so I can recognize you whether he or she? Sarang, can okay, Sarang, I can see your face now. Okay, all right, great. I can see your face now. Okay, all right. Okay, Sarang. To answer your question, okay, I think maybe some of you now already in USM. Okay, how many of you I mean how many of you now in USM? Can you jot down in the chat box so I can check? Okay, Navid, you in USM now? Okay, great. How about others? Jimo, are you in USM now? Okay, great, because I can recognize your background at the back. Okay. How about Aziz? How about others? Okay, Aziz, you're also in USM, right?
I'm in the USM.
Okay, good, good. All right. How about others? Okay, okay. I changed my question. Who are not yet enter Malaysia? Who are not yet enter Malaysia? Okay, all right. Maybe some of you, okay, Sarang asked me regarding the lab works, not lab works, the lab activities for this subject. Okay, these lab activities will be conduct on the maybe 11 weeks of 12 or 13, something like that. Okay, meaning that after midterm break, you still have another 2 weeks class with Prof. Hazizan, and then later we will arrange a lab for you. Okay, this lab is a part of the requirement for this subject. But Sarang asked me whether, let's say, if, okay, let's say if you have any issues to enter Malaysia, because now the situation is uncertain, right? Uncertain, meaning that some of you have delay in visa approval to enter Malaysia. That's number one, delay in visa approval. Number two, you also need to apply through Malaysian immigration to enter Malaysia, right? There's a lot of process later on. Okay, can we do like this? Okay, maybe maybe during the midterm break, okay, we will check back all your status. Okay, all your status. Okay, for who are already in USM, no problem. Okay, it's easy. Okay, but who are not yet, maybe we need to think to do like a record session like we did, like I did for my YouTube videos. Okay, so meaning that you can do some hands-on. Okay, so we need to think something that we can do Facebook Live, or any kind of medium. Okay, who are not cannot enter Malaysia yet. Okay, then let us decide. Okay, how to do it. But in your side, okay, please follow up regularly your entry application. But I do understand if you have any restriction to travel, uh, in our side we need to do something on it. Okay, but normally that's why I made this video last year, because last year all of the students cannot enter Malaysia. So that's why I took my initiative. I do my own lab briefing and also the demo from the videos, and easy, and then everybody can watch, and then we can do discussion like this online. Okay, so don't worry, Sarek. Keep updating us. Maybe we will ask your status maybe during midterm break. Midterm break another 4 weeks time from now, 1 month from now. Okay, if no news at all, so we will capture your feedback, and then we try to work on that, how we can do in order to cater, especially who are not enter yet USM. Okay, so any question more from either than Sarang, because I not plan to answer, because for me it's difficult for me to write. Okay, too long the answers. Okay, maybe any question other than Sarang question? Okay, if not, and that's all for our class today. I hope everybody can take home message what I tried to say today. Okay, remember my class. I don't like to, I don't like to uh, teach you what word by words what I wrote in the slide. Okay, the slide just a guidance for you. Okay, the important is that the message that I want to say during my lecture, because sometimes the information that I share is I didn't include in my slide. Okay, please remember when I say please take note or please jot down, meaning that that's really important for your either for your exam, for your test, as well for your other assessment. Okay, if not, thank you very much again. We meet again this week on Wednesday 6 p.m. Okay, thank you very much again. Have a nice day. Please take care of yourself, and then happy study. Okay, bye.